Okay, so in our last lecture we have learned about the triangle law to add vectors. Now just a brief recap. This is how we represent a vector. Say this is the tail of a vector, that is the tail, and this one is the head of the vector, and this is the vector from the tail to the head. This is how you represent a vector. This vector quantity a may be displacement, a may be force or whatever, velocity. Okay, and this and the length of this line, represents the magnitude of the vector, and you can write the magnitude of vector a as simply a or mod sign over a. Okay, now we know from our last lecture how to add two vectors, that is the triangle law. Say let's look at simple displacement vector. Suppose the displacement happens from here to here, say a, and then from here to here b, and this is the angle between the two vectors theta. See, this is the direction of a, this is the direction of b, theta is the angle between vectors a and b. So this is how you calculate the resultant vector r. So r is equal to a plus b. That means if a car is going from here, say from this point to this point, and then takes a turn like this, goes from this point to this point, so resultant displacement of the car is from this point to this point. Okay, right. So, and there also we have learnt a formula. If the angle between two vectors is theta, if this length is a and this length is b and this length is r, then you know r square equal to a square plus b square plus 2ab times cos theta. Okay, now we can add force vectors also in the same way. It is not only for displacement vector, it is this rule, triangle rule, is for all vectors. Okay, and that we have shown in our last lecture. Now we'll see how to add more than two vectors. So adding more than two vectors, the law we apply is Polygon law. Polygon law. It is very simple to understand it. Suppose for this case, say I have a car and the car moves from this point to this point. Let's draw the displacement vector. It has started at this point and going to this point. Okay, displacement of car from here to here. Then again, suppose it goes from here to here, so this again displacement, and again it takes a turn and goes from here to here, there, and again it takes a turn and goes from here to here. So this, so there are four displacement of the car here, say vector a, vector b, vector c and vector d. So what is the resultant displacement of the car? It's from here to here. So this is the resultant vector, this r. So the rule is you join the vectors, join tail, head to tail of the vectors, join head to tail of the vectors, then resultant is from tail of first to head of the last one, tail of first vector to head of the last vector. Okay, so you can write here like this r equal to sum a plus b plus c plus d. This is the polygon rule. It is similar to triangle rule, just keep on placing the head and tails like this. Draw the vector, okay, place the tail of the second vector, join it with head of the first vector, then tail of the third vector join it with head of the second vector, and go on like this. This polygon law is not only limited to a plane, it can be in space also. It can be in space. The cars won't fly, they fly in cartoon movies. Suppose it's a tiger, see, little tiger. So the tiger goes from here to here, and then tiger goes from here to here, right? And it has to jump on top of a tree, and say it gives a vertical jump there. So the displacement happens to be like this, a little vertical jump. See this one, this. So tiger goes from here to here, here to here, and jumps. So the resultant displacement of the tiger is from here to here, see. So the resultant vector in this case is joining which one, this point to this point, yeah, this one. So it is not only limited to a plane, it can be in three-dimensional space also. So here just a brief 3D diagram for you, that this side of the page I will use. Say this is a plane, or say this a tree over here. Tiger, this is ground, tiger moves from here to here, and then here to here, and then climbs up the tree, this. So these are the three vectors, got it now? This is in the horizontal plane, this is a horizontal plane. So that's the resultant vector, right? Say that's vector A in the horizontal, vector B also in the horizontal, and then vector C here. Okay, so resultant vector is this one, R. Here also I can write R equal to A plus B plus C. Okay. Again, you can add force vectors in this way also. Suppose in case of forces, see, let me show you. Say this car is being pulled by, we have already shown how to add force for two vectors. Suppose you have a rope and you are pulling the car like this. See, these two strings are being pulled from two sides. So you apply forces. Yes, force is in the length of in the direction of length of the string. So you apply two forces. Here it is F1, and here it is F2. Okay, so you can join this, you can find vector sum of these forces. Okay, which way is the car going due to these two forces at this moment? No, should go this way. It goes in this direction. So this is resultant vector, and you see this is how you can add the forces. So that's force F1, and I know triangle law only. So this I will parallelly shift to add. See, this is vector is parallelly shifted, F2. Okay, just I shifted F1 and shifted F2 also. So there it is, tail, head, tail and head, and this is the resultant vector. See, this is where the car will go. It is applicable for, I mean, if you apply forces on a body like this, say there is a ball and you split by three forces, F1, F2 and F3, then also you can apply polygon law in the following way. Say, draw this F1 vector first, draw this F2, and draw this F3 like this. See, it's all parallel shifting, and this is the resultant vector R. R is equal to F1 plus F2 plus F3. Okay, and also this vector sum, it obeys the commutative law. That means, see, if I am showing it by triangle law only, this is vector A and that's vector B, and this is the resultant of A and B. So this R equal to A plus B. Now if you draw it like this, first you draw B, second you draw A, parallel shifting, then you get B plus A. This vector is B plus A, right? Now this A plus B is exactly same as B plus A. So vector addition is commutative, follows commutative law. Okay. Now for if you apply triangle law, in some cases you may get theta as an obtuse angle. So A and B, this may be an obtuse angle theta, and you know the formula how to find out R. R equal to A square plus B R square, A square plus B square plus 2AB cos theta. For an obtuse angle, how to find out sine and cos theta? I'll just give you a formula, and it will be discussed in details in your maths class, that for obtuse angles you can use this formula: cos of 180 minus theta equal to minus of cos theta, and sine of 180 minus theta is equal to sine theta. This is the way to add angles. In a video later I will discuss briefly how to find out sine and cos and tan of any angle, maybe obtuse, maybe more than 180 degree or whatever, of general angle. In some video I will give it, okay, or else you will learn it in your maths class properly. Okay. Now we have added the vectors, right? So that means, say A plus B is equal to R. Okay. Acha. Now we will learn about a null vector. A null vector or a zero vector. Null vector or a zero vector is a vector of magnitude 0, and its direction is indeterminate. That's one way of saying that direction can't be determined, right? Obviously direction cannot be determined. You see where you are going. Say I am going from here to here. So if a vector has got a finite length, then the direction matters. I am going from here to here. Okay. Now if a vector is having magnitude 0, then obviously I am going from where? I am not going. So which direction you are not going? The question itself doesn't make sense. Okay. So how do you get a null vector? See, here you get a null vector. Suppose this is vector A. Now see, by a very practical example, I'll show the tiger goes from here to here and the tiger returns to its home here to here. What is the resultant displacement of the tiger? 0. Okay, so this is how the vectors are. A, we can write here A plus B is equal to 0. 0, it deserves an arrow, though it is 0. still it's a vector. You have to give that much respect. By the way, you can also write without this arrow also. Simply you can write 0. That is good enough for describing a null vector. Okay. Now see, this a plus b equal to 0, that means what's b? B is minus of a. So this is how you define negative of a vector. Negative of a vector. So negative of a vector is, say, if you have a vector a here, then negative of a vector is this one, right? Negative of a vector is, say, negative of a vector a is opposite to a, but having or has magnitude same as that of a, right? So that mod of a is equal to mod of minus a is equal to a. The length itself is, length is simply a, right? So its direction is opposite. So actually we can also subtract vectors, subtraction of vectors. Okay. Now suppose you want this a minus b. How to determine a minus b? So here, suppose that's a and say it's b there. Now we know the subtraction of vectors is a minus b, that is a plus of minus b. Now a plus of minus b means you have to draw this minus b, this is minus b, and we know the triangle law to add two vectors. So that's a and that's minus b, and this is the vector a minus b. And if you know the angle between a and minus b vector, you can determine. See, by the way, minus b vector has length how much? Its length is b. Okay, suppose vector a has length a, vector b has length b, vector minus b also has length b. Now suppose you have been asked, say if theta is angle between a and b, find magnitude of a minus b, magnitude of a minus b. Or it can be asked like this, find mod of a minus b. That is good enough. Mod means magnitude of the vector a minus b. So it's like this, a and b are having angle theta between those. So that's a and b. If I draw here, wherever it is, you can shift it parallelly and draw. This angle is theta. So now I will draw minus b here, minus b, and this angle will be 180 degree minus theta. So angle between a, see this is the direction of a and this is the direction of minus b, that's 180 minus theta. So this is vector a minus b, and this length, its length is mod of a minus b. Its length is mod of a minus b. So mod of a minus b is square root of what? See, this length is a square plus b square plus 2ab cos of this angle 180 minus theta. So that's a square plus b square. See, cos of 180 minus theta is minus cos theta. So minus 2ab cos theta. Okay. Now we'll discuss one more law to add two vectors, that is the parallelogram law. Parallelogram law. In parallelogram law, suppose these are two vectors A and B you have to add. Instead of joining head to tail, you join tail to tail. So that's A, and wherever it is, shift is parallel. That's B, and this is theta. And after joining tail to tail, complete this parallelogram. And just draw this diagonal. See, this is R is equal to A plus B. See, it is not different from the triangle rule, because in a parallelogram you have to find the diagonal. See, I will write the magnitude only. So this is A, see, as this is vector A here, this length is A and this length is B. If this length is B, this length is also B, parallel and equal, opposite sides. So it is the same thing. Obviously we will get same result by any law you apply, whether parallelogram law or triangle law. This law is applicable for adding two vectors only. Okay, so for two vectors, which all law we have learned? To add two vectors you have triangle law and parallelogram law. And many vectors or more than two vectors, you have, till now we have learned Polygon law. Okay.